Alright, now what I wanted to do was to go more in depth as to what the graphs of the higher order derivatives actually do. So the first derivative is position. So this is the graph of the actual positioning function. Okay, it's 3x cubed plus 4x squared minus 5x. So if I do the derivative, I'm going to get this graph. Okay, so last time we talked about the first derivative being velocity, and this time we're going to actually explain how velocity and acceleration are going to be showing up. So this is really kind of cool. Okay, so the first function is the function of this. So we have to talk about what it's doing as we're going, just to see what's going on. Okay, so let's bring it down a little bit. Okay, so right here, if I look at my position is increasing, and it's slowing down, and it's getting to the very tippy top, and then it's going to come back down, speed up, and then some point in the middle, it's going to start slowing down till it gets to the very bottom, stops, and then it goes right back up. So it's seriously a roller coaster. Okay, roller coaster of emotions. Now, my velocity here, so you can look at it without the actual function. Okay, my velocity is decreasing with speed, and then it gets to a negative value, so it gets negative right there, and it stops and it comes to a halt. So the velocity is I've come to a halt, and it's almost like a turning around point. So I start increasing, it continues to go on. Okay, now this third derivative is actually a line, and this is the acceleration. So my acceleration is always constant. It's always constantly going up. But if you notice here below the x axis, it's negative. So I have negative acceleration until here about negative 0.44. I start getting positive. Okay, and then over here at the x-intercept of 8, which makes sense because the y-intercept of 8, I start getting a positive x value. Okay? Alright, so here's the cool stuff. Let's overlap these two. Now, here's some interesting things. Okay? Alright, so if I zoom in a little bit and I take a look at some points. Okay, so here's my position, 1.31. Guess what? The x-intercept of my second derivative is where it dips below the x-axis. And look at that. I start going from a positive position to I start going downhill. So whenever your second derivative, your first derivative, when it hits the x-axis, that's called a critical point or a point of extrema. Okay? And you can actually tell what's happening to the position. I'm actually going into a negative velocity. Okay, I'm decreasing in position. It's almost like I'm slowing down. Now here's another cool thing. Ready? Okay, if I click down here at the bottommost point, negative 0.44. If you remember, that came up with the second derivative. Well, negative 0.44. If I drag down to this point, guess what? That's the halfway point to where I stop going downhill so fast and I start slowing down. So when you go down a roller coaster, you start going down real fast, and then all of a sudden you start slowing down because you're reaching the bottom of the hill. And so whenever your first derivative reaches its minimum, your first function, your primary function, is actually going to have a point of turning. Okay, so that's a critical point right there. So that's how you can overlap these two and notice it. Okay, and then all of a sudden my graph starts going up. Now this one's going to be kind of hard to see without zooming in. If you notice, they don't intersect right at the vertex of that point. Okay, but that's 0.42. All right, guess where my velocity function crosses? Yes, it's at the same. It's at 0.42. So in other words, what my first function is saying is that I've reached the lowest point. Now I'm going to climb uphill again and start increasing speed. Okay, whereas this function is saying now my velocity is going to be positive because I'm just increasing my speed. Okay, so it's really kind of cool. So it's kind of hard to see, but don't think of the first derivative as your
I'm going to go so I don't miss and I
don't think of the first derivative as position, but rather speed. So right here, we have positive speed, and all of a sudden negative speed, zero speed, negative speed, positive speed, all the way up. So, I mean, it's really interesting to just see how it works. It's really cool. Okay? All right, now if I overlap the first with the third, well, actually the first with the second, you'll see something cool. Okay? I'm going at a constant rate. Okay? Now, if I click off these x-intercepts and I click on the x-intercept here, if you notice, it's going to be negative 0.444, okay, which is the same as the bottom of my first derivative. It's the minimum of my first derivative. That tells me where my acceleration is going from negative to positive. Okay, and if you overlap that with the first, that makes sense because I'm not decreasing in speed. So in other words, I'm decreasing in my position. I'm decreasing. I'm slowing down. Now I'm going negative, and then all of a sudden I stop and I start slowing down and going positive. I'm slowing down the negative. So it's a really interesting concept that you can look at all three graphs, especially of higher order functions, and you're able to see some really cool stuff. So we will talk about this on another time, but guys, these are called critical points. They're so amazing in how they work. We don't care about the intersections because technically all three don't exist at once, but we do care about what each graph is saying of a derivative. Okay, so I will talk to you guys later. Have a wonderful day.